Hey, we're videoing.
Ew.
Arakawa, we got that on video.
Wait, what?
You know what I'm talking about.
You think your nose?
I don't know.
No.
Video can't even see
Somebody said, I hate you.
Oh, that was Kim.
It was Kim.
Wait,
That was Shelby.
That's what I said.
I didn't say anything.
So nice.
Just go home, cook rice.
Okay, questions on the homework. Now is the time to ask. Go.
33 AB. 37 AB. Beat you to it, Noah.
I'm crying.
I hope the camera didn't see that.
Shelby, you kill me.
Charlie, why are you sitting there?
So I don't get in the video.
You're dumb because I don't even get in the video.
But I stand
You know
up a
how I know
lot.
that? Because I actually watch the videos.
I watch the videos too.
Okay, so
Catering.
the first thing you should do is actually plot this point. Okay, so starting from here, you measure off an angle of 3 pi, so 2 pi plus pi, that would be here then, right? And then you gotta go 2 units in the opposite direction, so that would be right there. So did you get that point?
Yeah.
Okay, so in problem 33A, it says, plot each point, that's a double, you did that already. And then now find another polar coordinate for which A, R is positive, and the angle is in between negative 2 pi and 0. Okay, well, if you want R to be positive, how far are you from the origin? How far are you? 2. And we want this angle to be less than 0, but greater than or equal to 2 pi. So can I put 0 there? Because look, that's 0. Can I put 0?
No.
No, because 0 is like, it's not less than 0. So what would happen if I go 2 pi clockwise? Wouldn't that be negative 2 pi?
Yeah.
Yeah, that's what they want. They just want you to label it a different way, but they're giving you directions on how to do it. And then on B, what does B say? R is negative, and theta is less than or equal to, greater than or equal to 0, but less than 2 pi. So we want R to be negative, so obviously you gotta use the negative 2, right? You gotta use the negative 2, but then we want the angle to be between 0 and 2 pi, so where do I want the angle to be then, if I'm gonna go 2 in the opposite direction? Don't you want the angle to be here? So what angle is this over there? Isn't that pi?
Yeah.
Does that fit the conditions? Is pi between 0 and 2 pi? Yeah. So that's what they want. So they just want you to label it in a different way, but they're giving you the directions on how to do it. And then 37AB, I'm sure is the same thing. Yeah. Yeah. Okay, so draw the picture first. 1, 2. So you guys have the graph paper, right? It looks like that. So you measure off an angle of negative pi over 4, which is negative 45 degrees, which is there. And then you gotta go 3 units in the opposite direction, which would be over there. That's the point. Do you guys get that at least? Because if you don't draw the point correctly, you can't get it. Okay, so A. We want R to be positive. So how far from the origin am I? 3. And we want the angle to be between negative 2 pi and 0. So that means I want to go clockwise this much. So from here, if I go clockwise, what is that? That's negative, no, that's pi plus pi over 4. Pi plus pi over 4.
5 pi over
Thank you. And then B, we want R to be negative, so obviously got to be negative 3, but if it's negative 3, that means the angle got to be right here then. And we want that angle to be between 0 and 2 pi, so what would be this angle here? Pi, 3 pi over 2, and then what's that one right there? 7 pi over 4. Plus, on your polar graph paper, doesn't it have like all the angles labeled?
Yeah.
So isn't it like really easy to figure it out? Anyway, the point of all of this is there's an infinite number of ways of labeling a point. Now, I am happy if you can just give me one. So like I told you last time, the most normal way of doing it is r is positive. So like for example, if you have this point here, this is the most normal way to do it. How far from the origin are you? 3. What is this angle here? Nah, 3 pi over 4. If you can do that, I'll be happy.
The test is, are you gonna like ask us?
No, I'm not gonna ask you. Believe me, there's more important problems than that. But the main point is there's an infinite number of ways of labeling a point. If you can just do it one way, I'll be happy. And the way that most people want you to do it is this is positive, and that angle is between 0 and 2 pi. That's the most normal way. That would be good enough. Okay, is that it then? Okay, we can finish early today. Okay, so what we have to do today is we're going to have to convert from one to the other.
What do you mean convert?
Like I'm going to give you polar coordinates, you got to convert it to rectangular.
Oh.
I'm going to give you rectangular coordinates, then you got to convert it to polar. I'm going to give you a polar equation, you got to convert it to a rectangular equation. I give you a rectangular equation, then you got to convert it to polar. So yeah, the fun begins now, and then tomorrow, except I'm not seeing you tomorrow, Wednesday, then we're going to start actually drawing these graphs.
Like are the flowers apart?
Yeah, but that's going to take us several days for us to get to the level where we can draw a flower. We're just going to start with lines and circles.
Is it still 10.1?
Oh, this is still 10.1. Okay, so let me draw the picture. You can derive all the formulas just from that picture I drew you last week. Now remember, in the rectangular coordinate system, we label the point x, y, and what does x represent? How far you come out on the x-axis. What does y represent? How far you go up or down, right? And in the polar coordinate system, we have r and theta. What does r represent? How far you are from the origin, or what's another name for that? A pole. So I use it interchangeably, pole, origin, doesn't matter. And then theta is this angle here. Now, we can derive all 4 formulas just by looking at this picture. For example, applying the Pythagorean Theorem to this, you get r squared equals x squared plus y squared. Tangent theta is equal to, come on, SOHCAHTOA people. Tangent theta is opposite over adjacent, which is, what? No, tangent theta is opposite over adjacent. So what do I write here? Y over x. See, that's 2 of the 4 formulas just by looking at the picture. What about cosine theta, Mr. Park? Cosine theta equals adjacent over hypotenuse, so that's x over r. Now that's not the way we remember it though. So if I multiply the r on this side, you get x equals r cosine theta. How many of you are taking physics now?
How much you done the ratio?
Only 2 people. Now, yes or no? In physics, do you have to have the skill? You guys should learn this, you know. If you have a right triangle, you know this angle and you know the hypotenuse. Therefore, this adjacent side is h cosine theta.
Yes.
Doesn't that come up a lot in physics? How do you find this opposite side here? It's h sine theta. So, for those of you who are taking physics next year, if you can remember this, just go dominate. This is how we componentize vectors, it's like.
What?
Componentize vectors. And you know how you get this is from here. Because cosine theta, here, let's write this out. Okay, let's say you don't know what this is, call it box. Cosine theta is equal to adjacent over hypotenuse. Box over hypotenuse. Therefore, what is the box equal to? Multiply the h on this side, you get h cosine theta. See, but instead of doing that step, you just do it. If you know the hypotenuse at an angle, the adjacent side is h cosine theta. The opposite side is h sine theta. Believe me, in physics, you guys probably just gonna forget this anyway. How dare you? And then what about sine theta? Sine theta is equal to, look at this right triangle, opposite of our hypotenuse, y over r. So if I solve for y equals, move the r on this side, r sine theta. There you go. These are the formulas you need to know for tonight's homework. This is all printed in the book, copy it down, whatever. Okay, so here we go. What if I give you polar coordinates and you have to convert it to rectangles? So, convert to rectangular coordinates. Just spell out the words. Rectangular, because I don't even know how to abbreviate coordinates. Okay, let's start off easy. Problem number 1. 2 comma pi over 3. I'm going to do both degrees and radians now. Okay, now the easiest thing to do when you convert from polar to rectangular is just use these formulas right there. Just use the formula. Now actually, you don't need any formulas. You could actually, okay, let's pretend you're on the quiz. Mr. Park, I forgot to memorize the formulas. Can you still do these problems? Yeah, you draw the picture. So, boonga, boonga. Okay, so you measure off an angle of pi over 3, which is 60 degrees, which is like this, right? 60 degrees. And then you go 2 units from the origin. 1, 2. Now, even if you don't know any formulas, can I convert this to rectangular coordinates? Yeah, you just draw this triangle. Isn't that 2? Isn't this 60 degrees? And in a 30, 60, 90 triangle, if you know the hypotenuse is 2, what's this? How do you find the short side?
It's
You half it, it's 1. And if you know the short leg of the triangle, how do you get the long leg? You multiply it by radical
3.
3. So therefore, what are the coordinates of this point up here?
1 radical.
1 to the right, and then radical 3 off. Boom! So even if you don't know any formulas, you can just draw the picture, just make a right triangle. You can figure it out, right? But it's a lot faster if you just use the formulas. So this is how you convert to rectangular. X equals r times cosine theta, right? This one. And y is equal to r sine theta, which is that one. And then now you just got to know your trig values. Is that going to be a problem? You got to know your trig values, people. So, what is cosine pi over 3? We need another speed quiz? Do we? It's a half. What is sine of pi over 3?
Root 3 over 2.
Root 3 over 2. Multiply by 2, the 2's cancel out, so you get 1. The 2's cancel out here, 3. So you get 1 comma radical 3 as your answer. Hey, that's the same thing as that. You know what, Mr. Park? I think I'd rather just draw the picture. I don't care what you do, just get that. Okay, let's do another one. How about 6 comma, no! 4 comma 7 pi over 4. Okay, to me the fastest way is just to use the formula. So x equals r cosine theta, y is equal to r sine theta, right? Okay, now you just gotta know your trig values. What is the cosine of 7 pi over 4? Boom, what's cosine there?
Maybe 1/2.
What?
No.
Okay, here's the unit circle. There's 7 pi over 4. What is the x coordinate of that point? It's in the middle, people. Medium. Have we forgotten these already?
1/2.
Root 2 over 2.
Root 2 over 2.
What's up, boy?
Yes, Chun.
What is the side of 7 pi? What is the y coordinate of that point? So you gotta come down.
Negative root 2.
Negative root 2 over 2. Come on, the one in the pi over 4 ones, those are the root 2 over 2 ones, remember?
Right,
And then the 30 and the 60, that's the root 3 over 2 and the 1/2. Aye. So 2 goes into 4 2 times, so you get 2 root 2. 2 goes into 4 2 times, so you get negative 2 root 2. So if you want to convert this to rectangular coordinates, it's going to be 2 root 2, comma negative 2 root 2. There. Mr. Park, I don't know any trig values, I forgot everything. Okay, let's pretend you forgot stuff. Let's just pretend. Like I said, you don't have to use the formulas. You can actually just draw a picture. Okay, measure off an angle of 7 pi over 4. Right there, and then go 4 units from the origin. 1, 2, 3, 4. Right there. Okay, so can I figure out the rectangular coordinates at this point? Yeah, just draw a right triangle right there, and you just gotta figure out that and that, right? So you know this is 4, this is a 45, 45, 90 triangle. Now in a 45, 45, 90 triangle, if you know the hypotenuse, how do you get the short leg?
Root 2.
You divide it by
Root 2.
root 2.
Oh, yeah.
What about this one? Could be the same because it's an isosceles triangle. So the rectangular coordinates of this point over here would be 4 over root 2, negative 4 over root 2, right? Correct?
Correct.
Because you gotta go right and down. Isn't that the same thing as that? If you simplify it? Yeah, so you don't need the formulas, but it's just a lot faster if you use the formulas. Because otherwise, you gotta keep trying to picture, see, this way, whatever. Just make sure you can do it. Okay, now, what about the other direction? What if I give you rectangular coordinates and you have to convert it to polar? Okay, I'm gonna erase this. This is on video anyway. Okay, so convert to polar coordinates. Okay, example 1. Okay, let's do an easy one. How about, let's do one in the first quadrant, that's always easy. 2 comma 2. Now, this is what the book tells you to do. The book tells you to use these formulas. See, if you want to convert from polar to rectangular, you use these. If you want to convert from rectangular to polar, you use these. But believe me, you don't want to do that. The best way to do it is to just draw the picture. Watch. Okay, plot the point 2 comma 2. If I go 2 to the right, then 2 up, aren't you there right there? See? 2, 2. So polar coordinates, you just gotta figure out how far you are from the origin. Well, if this is 2 and that's 2, what's this? It's a 45, 45, 90 triangle, people. In a 45, 45, 90 degree triangle, if this is 2 and this is 2, what's the hypotenuse? You multiply it by root 2. Oh, so it's 2 root 2. And then, what's that angle right there? It's 45 degrees. Finished! Because otherwise, this is what the book tells you to do. I bet you all the other trig teachers teach it the long way too. Why you want to do the long way when you got the short way? This is what they tell you to do. This is x and this is y. So r squared is equal to 2 squared plus 2 squared. So that's equal to 4 plus 4, and that's equal to 8. So if r squared is equal to 8, what is r? The square root of 8, or, well, it's actually plus or minus the square root of 8, and that's going to be plus or minus 2 root 2. And then you have to decide whether you want r to be positive root 2 over 2 or negative. But see, if you just do it the way I do it, then you just pick the positive one every time. Okay, now to get the angle, tangent theta is equal to y over x. So here's y and here's x. So you get 2 over 2, which is 1. Tangent of what angle is 1? Well, you got 45 degrees, but then don't you also have the one down here? What is this one? Come on, people, unit circle.
240.
No, 225.
That's what I said.
I got that on video. Plus, I gave you the polar graph paper, got all the angles on it. Galaccio, you got the polar graph paper. See, look, he's not even in class and he got it. Either that or he's just saying yes. Now, and then you have to decide, oh, which angle am I going to pick? See, so if you pick the 45 degree one, then you got to pick the positive 2 root 2. But if you pick the 225 degree one, then you got to pick negative 2 root 2. See, so that's why if you use those formulas, you got to think and you got to figure out which one am I going to use with which one. But if you just draw the picture, it's just so easy. You don't have to think. Okay, so the lesson is, don't do it the book way. Do it the park way. Yes?
What are we supposed to do if it's not 2, 2? Like if it's...
Okay, here's another example. Convert to polar coordinates. 0, negative 3. See, and if you do the book way, this would confuse you, because look, The book way would be tangent theta is equal to, what is it? Y over x. So negative 3 over 0. What's that? That's undefined.
Undefined.
Oh, so where's tangent undefined?
90 degrees.
90 and 270, right? But then which one you gonna pick?
90.
Wrong. No, you can use either. But then you gotta pick the correct R to go with it. That's why, don't do that. Just draw the picture. Look, if I plot the point 0, negative 3, isn't that right there? Yes or no? How far from the origin am I? How far from the origin am I? 3. What is this angle? Swing! 270 degrees. Finished. No need to use formulas, just draw the picture. How come you guys don't seem impressed?
Because you're using 0.
It doesn't matter. Okay, I'll do another one then. Another one?
Because we're being bamboozled.
Okay, here's another one. Okay. Negative 2 root 3, negative 2. Okay, if you're gonna do it my way, you just draw a picture. This is so simple, it's ridiculous. Go 2 root 3 to the left, and then 2 down. So this is 2 root 3, 2 down, like that. Boom! How far from the origin am I? Okay, let's pretend we know a little geometry. If one of the legs is root 3 times the other, isn't that a 30, 60, 90 triangle?
Yeah.
Isn't this a 30? Okay, and in a 30, 60, 90 triangle, isn't the hypotenuse always double the short leg? You gotta know this on the ACT and SAT people. So what is this without even thinking? 4, it's double the short leg. You gotta know 30, 60, 90, 45, 45, 90. Okay, so 4, comma. Now all I have to do now is figure out this angle like this. Yeah, but Mr. Park, this angle is 30 degrees because that's a 30, 60, 90 triangle, right? The short one is. See, the short leg is opposite the short angle, the small angle. So that means this one is 60, right? Anyway, so how do I find this angle going around like that? Well, this is 180, and then I gotta add 30 to it, so that must be 210. Now, if I don't specify whether to give degrees or radians, you can give either. So you can write either 210 degrees or 7 pi over 6, and I'll accept either. Shall we do one more?
Yeah.
Okay, let's do one more. I'm not gonna erase those formulas because we've gotta use them. Okay, let's do one more. Okay, example 4. How about, okay, wait. 3, negative 3 root 3. I'll give you a hint. Never mind, no hints. No hints. Okay, plot the point. If I go 3 to the right and 3 root 3 down, how far from origin am I?
6.
Very good, we got it. How come he knows it's 6 so quickly?
Because the short side's 3.
Yeah, because in a 30, 60, 90, the hypotenuse is always double the short one. Okay, so we know it's 6, and then all I gotta know is this angle going around like that then, right? Well, what is this? Is this the 30 or the 60 one? That's 60, so if this is 60, what's the angle going around like that?
3.
There's several ways you can do it. You can go 360 minus 60, or you can go 270 plus 30, 300 degrees. Or if you're working in radians, what would that be? Oh gosh. 5 pi. Have you forgotten there? How can you forget when you got the polar graph paper like right there? Okay, so basically this is my lecture. When you convert from polar to rectangular, you use these formulas. When you convert from rectangular to polar, you draw the picture. But actually, you can just do everything by drawing the picture, right? You don't need to use these formulas. Okay, now, of course, on the homework, they're going to give you some to throw you off. Here, I'm going to give you one to throw you off. You ready?
Go.
negative 2,
You're killing me
negative
now.
3. Convert this to polar coordinates. Okay, plot the point negative 2, negative 3. So 2 to the left and 3 down. How far from Oregon am I?
Four.
From Oregon?
Okay, who said 4? This is not a 30, 60, 90 degree triangle. How do I know that?
Oh.
Because in a 30, 60, 90 triangle, the long leg is radical 3 times the short leg. So if there's no radical 3's in there, then that's not 30, 60, 90. So if this is not a 30, 60, 90 or a 45, 45, 90, then how do I figure out the hypotenuse?
Pythagorean Theorem.
Pythagorean Theorem. Can we do it in our head?
Square root of 12.
Square root of
12.
13.
12.
13.
Okay, let's pretend we don't know anything. Let's call this x. No, we should call it r because r is how far you are from the origin. R squared is equal to 3 squared plus 2 squared, which is 9 plus 4, which is 13. So r equals plus or minus root 13, but we're going to take the positive one. Okay, so root 13. Now, I have to compute the angle. Remember, the angle always starts from here. Whoa! Now, how the heck do I figure out that angle? Well, let's erase this for now. Well, if I can figure out this angle, then wouldn't the answer be 180 plus that then? Okay, well, what's this angle right there? Come on, somebody impress me.
Wait, can you repeat the question?
Oh.
Can you repeat the question?
What's this angle right there? What is this angle? Somebody impress me.
No.
Cosine.
What?
Cosine.
Use a long.
It's sine.
No. You just look at it and go, blah, blah, blah.
Oh.
65.
45. 45.
How can it be 45? The only way you can get 45 is these two gotta be the same, right? Like 2 and 2. So this is 2 and 3, so it's gonna be bigger than 45.
50.
No, I want the exact measurement though, not like an approximation.
53.6.
What did I just say? I don't want. Okay, I'll tell you what it is. It's tan inverse
Oh,
3 over 2.
Oh.
So that's
Right? Because the tangent of this angle
So
is
last
opposite over adjacent, 3 over 2. So therefore the angle is tan inverse 3 over 2. You get it? So therefore, if this angle is tan inverse 3 over 2, how do you figure out the angle going all the way around? It's 180 plus that. So 180 degrees plus tan inverse 3 over 2. Now when you have this problem on your homework tonight, I'm not sure if your book wants you to leave it like this, or your book wants you to punch it in on your calculator and then add 180 degrees. Just look in the back. But for me, you know, when you do upper level math, you want to leave it like that. It's better, because that's exact. Ignacio.
Why is it inverse again?
from the angle.
Because, okay, call this angle theta. Tangent theta is equal to opposite over adjacent. So how do you figure out that angle? Don't you tan inverse, remember? This is the last chapter.
Oh.
Tan inverse 3 over, because tan
right.
inverse means the angle that corresponds to that, yeah? The angle whose tangent is 3 over 2. So some of the problems tonight, they're gonna give you like an ugly angle like that, where it doesn't come out to like a multiple of 30 or 45. So just be ready for it. Okay, and then the last thing on tonight's homework is now you gotta convert equations now. We're almost done. Okay, let's start up. Shall we start off easy? Yeah, okay. Which direction are we gonna go? You know what? I'm gonna give you a polar equation. You convert it to a rectangular equation. Okay? R equal 5. Now, if I were to just ask you, okay, before we even start, okay, the directions are convert this into a rectangular equation. Convert to a rectangular equation. Whoosh. Example 1.
Triangle.
Okay, now, forget what the equation is. Can you just think of what the graph looks like now? What does R represent again? How far you are from the origin, right, or the pole. So think about it. The distance from the pole is always 5 units. What is that graph gonna be? If you are always 5 units from the origin,
Circle.
yeah, isn't that just a circle of radius 5?
Yeah.
See, and that's why we learned polar coordinates. This is the polar equation of a circle with radius 5. It's r equal 5. Okay, but how do you convert it to a rectangular? Now, you know what some students do? They draw the graph and then they convert it. No, you want to use these formulas right here. Now, which formula can I use here? Now, Mr. Park, this is r. The only thing with r in it is either this, or this. What do you think?
Last one.
No, we're going to use this one. Yeah, well, Mr. Park, that says r squared. So what do? Square both sides. So you get r squared equal 25. And then A, use somebody. Look right here. What can I substitute for r squared? X squared plus y squared equal 25. Bam, that's your answer. Hey, Mr. Park, isn't that an equation of a circle? Yeah. See, it's the same graph, except this is the rectangular equation of a circle. This is the polar equation of the circle. Which one looks simpler?
Polar.
Really? Doesn't this one look way more complicated than that one?
That's what we-
Yeah, and that's why we have these other coordinate systems, because certain graphs, right? Look, this is, so if you want to work with it, like you're doing, work with it, algebra or calculus, whatever, instead of doing this, you change the coordinate system and you just work with that. It's a lot easier. Okay, let's do another one. How about theta equals pi over 4? Convert this into a rectangular equation. Oh boy. Okay, I'll give you a hint. You're going to use this equation. Oh no. Okay, before we start, just tell me, what do you think the graph is going to be? So what does theta represent? Theta represents this angle here.
45.
But that angle is always 45 degrees. So if this angle always stays 45 degrees, r can be anything. R can be 1, 2, 3, -1, -2, -3. So what would the graph be? If this angle always has to be 45 degrees no matter what. Yeah, just be a line like this, right? 45 degrees, right? And if r is 1, that's the point. What if r is 2, 3, 4, -1, -2, -3, -4? See, all the points lie on that line. Okay, now you might say, oh, that's why y equal x then, right? Okay, so some students do it that way. They think of the graph and then they convert it, but we don't want to do that. We want to use these formulas. I'll give you a hint. We're going to use this one. Yeah, well, Mr. Park, I don't see tangent there. So what do you think I'm going to do? How can I put a tangent in front of the theta? You tangent both sides. You can always do the same thing to both sides of an equation. I'm going to tangent both sides. Just like in algebra 2b, didn't we like log both sides? Same thing, you can do that. Okay, so what is tangent theta? Hey, use some money. No, it's y over x. And tangent pi over 4 or 45 degrees. Hey, that's a number I'm supposed to know. 1, multiply both sides by x, and you get y equal x. Hey, that's the same thing as that. So this is the rectangular equation for that polar equation. They have the same graph, it's just that they have different equations because they have different coordinate systems. Okay, now those are the easy ones. Are we ready to kick it up a notch? Too bad we are. 2 more problems and we're done. R equals, give me a number, 3 secant theta.
Convert.
Mr. Park, I don't even see a secant over here. What do I do?
Change it.
Okay, what is secant? Secant is 1 over cosine, so 3 times 1 over cosine. So isn't that just the same thing as r equals 3 over cosine? Okay, now what can I do so I can start using these formulas right here?
Multiply both sides by cosine.
There you go.
And
Multiply both sides by cosine, so you get r cosine theta equal 3. And hey, use somebody.
R equals R cosine is
No, look. I'll point at it.
It's X. Yeah.
Use somebody.
It's X.
That's x. This is x. X equal 3. There's the rectangular equation. And we know what that graph is, right? What is the graph of this? How do you graph the line x equal 3? Here, let me show you. 1, 2, 3. It's a vertical line, people. See, so this is the equation of a vertical line in the rectangular coordinate system. That's the equation in the polar coordinate system. Which one would you rather do? Duh! This one's way easier, see? So depending on what you're doing, you have two different coordinate systems. Okay, last problem and we're done. Now, I saved the best for last. I need the whole board for this.
What?
R equal 4, we just did cosine, I'll do sine now. Sine. Convert this into a rectangular equation. Okay, this is the last one. Okay, now look at your formulas. Mr. Park, if that was r squared, then I could replace it with this, right? But then on the other hand too, if I had r sine theta, then r sine theta is y. I can also substitute it there. So what can I do to both sides of this equation to get like r squared? See, because look, r squared, you need r squared. That's only r. So should I square both sides? No. Multiply both sides by r. So you have two choices. To make this into r squared, I mean, yeah, you either square both sides or multiply both sides by r. Now, why is it better to multiply both sides by r? Because use somebody. Because if you square both sides, you just gonna get sine squared theta, and that's not even on the list here. But if you multiply both sides by r, that one's on the list. Use somebody. So what can I substitute for that? Use somebody.
X squared plus y squared
Okay? And then A, use somebody.
equals 4y.
4y, there you go. That's the rectangular equation. What is this graph? Chun, redeem yourself. This is algebra 2b right here.
Ellipse.
Pen.
Circle,
Izumo.
circle, 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 circle.
Okay, it is a circle. How did you know? How come you changed it?
Because x squared plus what? No, I don't know. I'm just confused.
Yes.
There's another
Okay,
one.
now, see, a lot of you don't even recognize this as a circle. So that's why, how do we put the circle into standard form? Remember what we did in algebra 2b? It rhymes with complete the square.
Complete the square.
Complete the square. So let me refresh your memory on how to complete the square. Oh my goodness. Put all the x's together, but see, this is the only x, so that's easy. Put all the y's together, so bring this over. Okay, leave the number on that side. Now, what number do I have to add right there to make a perfect square? You guys remember?
4.
You take half of that number and you square it.
4.
I heard 3 different answers.
4.
What is half of negative 4?
-2.
No, negative 2, and then you square it.
Negative 2, negative 2 before.
4.
Okay, 4. If you add 4 to the left, though, you gotta add 4 to the right. And so now we got x squared plus y minus 2 quantity squared, right? Complete the square equals 4. Now do you recognize that as a circle? Yeah. What's the center of the circle? 0, comma 2. And the radius is the square root of that number, 2. Now, I'm not sure if tonight they're going to ask you to draw the graph, but let's just draw the graph for funsies. 0, 2, that's the center, and the radius is 2, so... That's as hard as it gets in this class, for this chapter. Can you guys...
To draw the flower. Isn't that hard?
Yeah. But we gotta learn things in steps. Like the flower, what I showed you last week, that's like the last thing we're gonna learn. We have to learn the basic graph. So notice that we're not even graphing yet. I don't think they're gonna even ask you to graph tonight. Tomorrow, we start graphing, except I'm not gonna see you tomorrow. Wednesday, we're gonna start graphing, so hopefully you guys remember your graphing techniques. Okay, we are done. So you have 13 minutes remaining. What are you gonna do?
Homework.
Fool around. Homework? That would be good. Oh, I thought we were gonna finish much sooner. But we didn't.